Welcome back to Unit 8, Lines and Planes, Lesson 6, Intersection of Planes. So this is part 2 of the lesson. This time we're going to look at 3 planes rather than 2 planes. So we're going to be given 3 planes this time and see how they intersect. So a few more cases this way rather than the other way. The first one is when the planes, case 1, intersect at a point. And so here there is exactly one solution. They intersect right there. All right. The normals are not parallel. That's pretty obvious. Nor coplanar. Mr. Wills, what's coplanar? That means all the normals would lie on the same plane. So here, what does that mean? That means that they're not scalars. Normals are not scalars of each other. And this is a test for coplanar. If this is equal to 0, it's coplanar. But if it's not equal to 0, it is not coplanar. So that's case 1, one point of intersection. Case 2. Case 2a actually, the lines intersect in a line. So here there are infinite number of solutions because they all meet at this line right there, as I've poorly drawn. The normals are coplanar but not parallel, so they are coplanar. So what does that mean, Mr. Wills? N1 crossed with N2 dotted with N3 gives you 0, so that's coplanar. And again, they meet at a line. All right, it's another case. The next case is this. The planes are coincidence. Here, there are an infinite number of solutions. The normals are parallel, and also, so the normals are parallel also, this is not quite correct. The constants are also scalars. So d1 is equal to, I should have a little here, a d2, which is equal to b d3. So my apologies. Please put those in your notes. They're not in there right now. Case 3a, the lines are parallel but at least 2 are distinct. So here there are no solution. Here 3 are distinct. Here just 2 of them are distinct and 1 is coincident. Well, 2 are coincident and 2 are distinct. But again, what does this mean? This means there's no solution. The normals are parallel. However, d1 does not equal a d2, which is not equal b d3, or d1 does not equal a d2, or the third case is d2 b d2, or sorry, oops, a d2 does not equal b d3, or the third case d1 is not equal to b d3. So really, if any of these work, there are no solutions. All right, next one, here we go. The 2 planes are parallel and distinct, and the third is not parallel. So here, there are no solutions because there is no common point or line where the 3 planes meet. The 2 normals are parallel, and 1 is not. So here, n1 is equal to a n2, but d1 is not equal to a d2. And then here the normals are not parallel. So one of the pair is, one of the pair is not. Case 3c. The lines intersect in pairs. So I've really got 1, 2, 3, but there is no common one here. So here again, no solution. They are coplanar, but not parallel. So they are coplanar. So if you cross 2 normals and dot it with a third, they're equal to 0, but you can see they are not parallel. All right, Mr. Wills, that's a lot to remember. So here we go. Let's attack a few here. So here, I look at them here. First thing I want to do is I look at my normals. So here, normal 1 is equal to, if I multiply normal 2 by, if I multiply normal 2 by negative 2, I will get normal 1. And then finally, which is equal to, and if I multiply this guy by 1/5, I will get normal 3. So there we go. So the normals, what does that mean? They are parallel. Okay, let's look at the d values now. If I have d1, is this equal to negative 2 d2? And then this is equal to 1/5 d3. Well, let's look here. I plug in some values. 8 is equal to negative 2 times negative 4, which is equal to 1/5 times 40. And these are absolutely true. This is true. What does that mean, Mr. Wills? That means that the 3 planes are coincident. So there are infinite solutions. There we go. Okay, that's an E, by the way, and an N. All right, Mr. Wills, who cares? Modify the planes of part A to different ways to create a system with no solution. So here we go. The first one says this: 2 planes are parallel and distinct, and the third is not parallel. So here, 2 planes are parallel and distinct, so I'm going to keep plane 1 as is. So then I'm going to say this is going to be the same. Plane 2, however, I want to make it distinct, so I'm going to keep it as negative x minus 2y minus 3z, and here I'm just going to change the d value. So it was minus 4, I'm going to change it to minus 5 equals 0. So now these are distinct because the normals work, n1 is equal to negative 2 n2. However, d1 is not equal to negative 2 d2. So these are distinct now. And then plane 3, well, third one is not parallel, so what I can just do is change one of the values here. Let's see. I will change 10x plus 20y plus 31z, and then plus 40 equals 0. So here, because of this guy here, 31yz, wait a second. Nope. Let me fix that, sorry. Plus 31z. And again, because of this guy here, now this guy here is not parallel. So there we go. 2 are parallel. These 2 are parallel. And this guy here is not parallel. So there we go. All right, the planes are parallel, and at least 2 are distinct. So here we go again, same thing. I'm going to keep plane 1 as the same. Plane 2, I will also keep the same. So what does that mean? That means these are coincident. So they are definitely not. So these are definitely not distinct. But then plane 3, I'm going to keep 10x plus 20y plus 30z, and I'm just going to change that constant. So instead of plus 40, I'm going to do plus, oh, my favorite number, 16 equals 0. So here, that's going to change it, so that makes it distinct. So simply by changing the d value, I now have a distinct plane. But these 3 are all parallel. And there we go. All right, let's look at the next one. Determine if the following systems can be solved, and solve and describe, and then solve or describe it. So here we go. I am going to look at the normals first. So normal 4, which is equal to 1, negative 5, and 2. Normal 5, which is equal to 1, 7, negative 2. And normal 6, which is equal to 8, 5, 1. And here I can see these are clearly, oops, not scalars. What does that mean? Not parallel. All right, what do I do then? Well, what I'm going to do then is I'm going to cross N4 with N5 to check if they're coplanar. If I do this, I'm not going to show you this work because we've done lots of cross product. So I'm just going to write the answer. It is -4, 4, and 12. And again, if you want to check it out, check it out. It's actually in the notes. I did in the notes online, but I'm not going to show it here. And I'm going to dot that with, so N4 across N5, dotted with N6. And if I do this, I get 0. So I cross this with this guy here, I will get 0. What does that mean? That means they are coplanar. Okay, Mr. Wills? That means they intersect in a line or intersect in pairs. So I really got two possibilities. My two possibilities going back here are this. If they're coplanar, I've either got this, where they intersect in pairs, so 3C, or my other case is, going back one more, here, they intersect in a line. So those are really the two options for coplanar. Intersect in pairs, which is no solution, or intersect in a line. That means there are infinite solutions. All right, so two possibilities. And this is case intersect in pairs, that's 3C, or intersect in a line, and this is case 2A. If you go back to the notes. All right, how do we do this, Mr. Wills? Well, we're going to do the same thing as we did before. We're going to choose two planes. So go back to the first part of this lesson, choose two planes, and we're going to solve for one of the variables. Or we're going to eliminate one of the variables, my apologies. So I'm going to take plane 1 and plane 2. So here we go. So I'm going to take, plane 1. So I'm going to have here, x minus 5y plus 2z is equal to 10. So that's equation 1, and I'm going to have here x plus 7y minus 2z is equal to -6. All right, and I'm going to eliminate the z's. Why? Because I'm going to add here. So I get 2x plus 2y is equal to, that's a 10, not an 18. Okay, that's good to know. 4. So I'm going to let one of my variables here be, or sorry, I'm going to take another pair. So again, this was plane 4 and plane 5. So now I'm going to choose another pair here. Let's do an easy one here. Well, I'm going to have to use plane 6 some way. So I'm going to do plane 4. So plane 4 again, so x minus 5y plus 2z equals 10. And I'm going to do plane 6, but I'm going to actually do 2 times plane 6. The z value is the same, so 2 times plane 6. What am I doing here? Well, I'm going to eliminate the z's twice. So I'm going to have 16x plus 10y plus 2z equals, this is embarrassing, that should be, 2z equals 40. Good to go, all right. I'm going to subtract here. Now, I eliminated the z's from pairs 4 and 5, and I'm going to eliminate the z's from pairs 4 and 6. So I choose 2. Here we go, I subtract, so I get -15x. Subtract here, so minus 15y is equal to -30. And hopefully, some alarm bells are ringing here. Why, Mr. Wills? Because now I've got two equations here, equation 1 and equation 2. I'm going to multiply my equation 1 here by 15. multiply my equation 2 by 2. Why, Mr. Wills? Because I'm going to eliminate the x's here. So now I'm going to have 30x plus 30y is equal to 4 times 15 is 60. Beautiful. Here I'm going to have negative 30x minus 30y is equal to negative 60. And if I add these to eliminate the x's, I actually get everything eliminated. 0 equals 0. True. What does this mean, Mr. Wills? Well, if you get this, that means that the planes intersect in a line. Oops. So if you get that, therefore, the planes intersect in a line. What does that mean? We have case 2a. Woo. All right, so what do I do now, Mr. Wills? Well, you are going to take one of your equations. I'm going to take equation 1, and I'm going to let one of my variables be t. So again, so I check this. Now what if I got something that was false? If you got something that was false, let's say you got 10 equals 0, that means you've got case 3c, and there's no point of intersection, or there's no line of intersection, but there is a line of intersection here, so I actually got to solve it. So again, I'm going to take line 1, and I apologize about the messiness of this. I'm going to take my equation 1, and I'm going to let x equals t. Alright, well what do I have then? I will have 2t plus 2y is equal to 4. So y is equal to, I'm going to do a little bit of fast math here, I hope you don't mind. 2 minus t. Alright, so I've got this, x equals t, y equals negative, or 2 minus t, and then I'm going to substitute this into one of my other equations here. Well, let's go. Let's see, I will substitute it into the easiest one I know. Let's substitute it into plane 4. So I'm going to put these two into plane 4, which I cannot see at this moment. So plane 4 is x minus 5y plus 2z. X minus 5y plus 2z, I believe, is equal to 10. Yep. Plug these values in, so I get t. Let's give myself a little more space here. Minus 5 bracket 2 minus t plus 2z is equal to 10. So I get t minus 10 plus 5t plus 2z equals 10. Add like terms, t plus 5t is 6t. Bring it to the other side. So I'm going to have 2z is equal to negative 6t. And I've got a 10, so it's going to be plus 20. Really should have done the constant first. Divide everything by 2, so I get z is equal to, I'm going to put the constant first this time, minus 3t. So there we go. So there's my third, oops. So there's my third z. So what's the line of intersection? And again, I apologize, this is a little bit more messy than I had planned. So that means, therefore, the line of intersection is x, y, z is equal to, let's look at the constants. The constant for x is 0. So 0, constant for y is 2, constant for z is 10, plus t, and here we go, I get a 1. My y is negative 1, and then my z is negative 3. And there we go. So there's my line of intersection. Beautiful. Again, what did I do? Chose 2, eliminated I eliminated a variable, so I eliminated z, chose another 2, another pair, eliminated the same variable, I set up my two equations, I solved, and I got 0 equals 0, so it's true, so that means I have a line of intersection. If it was false again, what would happen here is I would have a pairs of intersections, so no solution. All right, let's continue. Here we go with 12. Determine if the following system can be solved and describe it. So this will actually be the last example. I'm not going to get into matrices. I just think it just takes a bit too long, which is a bit unfortunate. However, if you go to university and take an algebra course in university, you will see matrices for sure, but that's that. All right, I'm going to skip to the chase here. If I do n7 cross n8 dotted with n9, and first of all, they're not scalars, so that's okay. I can see I do not get 0. I actually get 60, I think negative 65, yeah, negative 65. So that means they're not coplanar. So what do I do here? Same thing I did before. I'm going to choose a pair. Since they're not coplanar and they're not parallel at all, that really means if I go back to my cases here, let me just go back here. So they can't be 2A, they can't be 2B, they can't be 2C, or sorry, 3A, they can't be 3B, and since they're not coplanar, they can't be 3C. So the only case I'm left with is they've got to be case 1. There's got to be one solution. So not coplanar, not parallel. We're looking at case 1. So what do I do here? Well, I've got to do what I did before, and I'm going to choose 2 and eliminate a variable. So choose 2 and eliminate a variable. Let's see here. I'm going to do plane 7, which is 2x plus y plus 6z equals 7. And I'm going to eliminate the z's here. So I'm going to multiply my plane 8 by 2. So 2 times plane 8. So I'm going to have here 6x plus 8y plus 6z equals negative 16. All right, I'm going to subtract because my z's are the same. So I'm going to have here negative 4x minus 7y is equal to, this is a bit tricky, 7 plus 16 is 23. There's my first equation. All right, I'll call that equation 1. By the way, this is 2, so I just multiplied this by 2. All right, so I did 7 and 8. Now let's do 7 and 9, and I'm going to eliminate z again. I'm going to make the z's here this time 12. So I'm going to multiply plane 7 by 2, so 2. 2 plane 7. 2 plane 7. So this is going to give me 4x. So this is really a good practice in algebra. And then I'm going to do, let's see here. I want to make this 12, so I'm going to do 3 plane 9. So here I'm going to have 3x minus 6y minus 12z. Multiply by 3 is negative 27, but it's on the other side, so it's equals 27. All right, there we go. And I'm going to add. This time, why add, Mr. Wills? Well, because my z's are the same number, however, opposite sign. So 7x, add this, minus 4y is equal to, and here I'm going to get 41. All right, so this is what I'll call equation 2. And now I'm going to eliminate either x or y. Which one should I do? I'll eliminate, well, they're both kind of the same here, so I'm going to multiply this by 4, equation 2 by 4, and I'm going to equation 1 by 7. All right, now it's going to get a little messy, but I can do this. So here we go. I'm going to multiply this guy by 4, so 4 times equation 2. So I'm going to get 28x. And what I'm doing here is, now I've got 2 equations, 2 unknowns, which is much easier to solve. 28x minus 16y is equal to 4 times 41 is, I believe, 164. It better be, or else I'm in trouble. And here we go. I'm going to multiply 7 times equation 1. So I'm going to get negative 28x, negative 49 y is equal to, need my calculator for this one, 7 times 23, I should know this. This gives me 161. All right, I'm gonna add because same signs. So I'm gonna do negative 16 plus, or sorry, minus 49, which gives me negative 65. And then add these two, 164 plus 161, which is 325. Divide both sides by negative 65. Oops. And I get y is equal to, here's my first one, 325 divided by negative 65 is negative 5. All right, there's my first one. Nicely done, Mr. Wills. Thank you very much. So to recap, I looked at the normals and not parallel. Checked if it's coplanar, it's not coplanar, so that means there's a point of intersection. I chose two equations, eliminated one of the variables, chose another pair, eliminated the same variable, set up my two equations, and now I solved. So I've got this guy. All right, so I've got y. So now I can substitute y into one of my equations. So I'm going to do this guy into equation 1 to solve for x. So negative 4x minus 7 times negative 5 equals 23. So negative 4x plus 35 is equal to 23. Bring that over, I get negative 4x equals negative 12. So that means x is equal to 3. There's my second answer. Beautiful. All right, Mr. Wills, how do you get the third? The third, I just choose one of my planes. I'm going to choose this, let's see, what plane should I use? I'll use plane 9. So I'm going to substitute this and this into plane 9. So here we go, I'll do it in green just for fun. So plane 9, I have x, but I know x is 3, so I'm going to have 3 minus 2 bracket negative 5 minus 4z minus 9 equals 0. I do some fancy math here, not really, just kidding. So that's 13 minus 9 is 4. So I bring that over to the other side. So here I get z equals 1. So I know my point of intersection now. I know my answer. Therefore, the POI is, drumroll please, the end of calculus and vectors, 3, negative 5, and 1. So if I plug that point in to these three planes, I will get 0 equals 0 each time, and I am done. So there it is. We checked out most of the different types. I'm not going to go through all the cases, but this is case 1, where there's a point of intersection. Normals aren't parallel, none of them are, and also they're not coplanar, means there's a point of intersection, and there we go. There's actually a different way of doing this. If you check out the next page, it says shows you matrices. I'm not going to get into this. We kind of ran out of time in this unit. Perhaps I didn't this year, but the first year I did it, I ran out of time. If you want to check it out, there's a full solution here. And then I also did the next example too. Again, if you're taking an algebra course at university, you'll probably see something like this. However, it's something you can see in this course if we have time. Maybe I did this year, maybe I didn't. However, the first year I did it. In 2018, I didn't. But there it is, matrices. It's wonderful. Thank you for listening. Thank you for your patience.